there is a correlation, and they could look for more variables, explain to you that they are in the error term, and for that reason, there is a correlation. So you must do everything possible within your means to explain and argue your point out. If you meet an economist sitting under a tree and crying, it is because the person cannot find an instrument. Finding an instrument is one of the most difficult things ever. But at least yours is to keep pushing, find an instrument, argue your point out, because the exclusion restriction assumption is one of the most important parts in your journey. So let's start from here. In this error term, we have innate ability, as I already indicated, and because of that, the covariance between the X, which is education, and the error term is not equal to 0. So the Gauss-Markov assumption is violated. So this is violated, and then we say that the instrumental variable is correlated with the explanatory variable. That is relevance. Now let's start from a simple regression where we have education influencing wage. So the effect of education on wage is 0.109. We feel that there are other variables that could also influence wage, right? Age, experience, and all that, but they're not in this model. So the point here is that the return to education probably is overestimated. And as to whether the parameter is overestimated or underestimated, you compare that of the OLS with the IV version. So we go through the 2 steps where we now introduce father's education into the 2-step procedure. I'll move to a Word document, probably try and structure it for you to see how it works. Then this is your first stage, that's your second stage. So let me use a Word document to explain this to you. You have wage here, you have beta 0 plus beta 1 age plus, let's say, the error term. Trying to make this quite simple. Is this understood by everyone here? So I can probably make time to explain. If someone doesn't understand, let the person tell me so I can go through the steps. So we have this being the intercept. We have this being beta 1. We have age. Now, the 0.10, I didn't keep the figure, which we found is for wage. Now let's go through the 2 steps. First step is trying to disentangle the effects of the instrument, which is the father's education, from this. To do that, this is your first step. Now you make wage the dependent variable. So this should have been education, right? And no one told me. So let me copy this, put that here. In your first stage, you make education the dependent variable. Now you introduce father's education here. So this is your first stage where you estimate the influence of, let's make this one alpha, this alpha. Once you have estimated the effect of father's education on the child's education, you need to predict this, which we call the Y hat in Stata and all that. So here you predict education. Once you predict education, you have now factored in, if I was using, let's say, the mathematical notation, This one becomes education. And then we find where alpha is. In your next step, once you predict education, after you have factored in the influence of the father's education, that predicted education becomes the education hat. So here, probably need to insert a new one. This is what I'm talking about. So this education hat now factors in the father's education. So you move to your next stage, which is the second stage. That second stage will have your main model, where you've got wage. Let's make this one beta. And then here, this is what you need. So can you spot the difference? Initially, we wanted to know the effect of just education on wage. Now we've gone through the first stage where we have made the father's education influence the education first. We have now replaced this education in the model with the education hat. This education hat is the predicted education after you have factored in the father's influence. And so it's more or less as in removing the father's influence from the child's education before allowing that to influence wage. Now let's talk about the father's education as an instrument and probably argue things out. If you don't get the explanation clearly, we can proceed. The father's education satisfies the relevance assumption because it has an influence on the child's education. I already indicated that people who are highly educated would also want to see their children being educated. In research, you can also argue that there are some people who also feel that they are not educated, they've lost out on certain things, so they would want their children to be educated. But in statistics and in research, we think about the average. On the average, people who are highly educated have their children also being highly educated compared to those who are not. And that is why this satisfies the relevance condition. The exclusion restriction condition is that if a child, as in any of us here, happen to apply for a job, how much we are paid is based on our education. Your employer will not ask you if your father is highly educated or not before your wage is considered. So your father's education does not have a direct influence on how much you will be paid. But if your father's education can influence how much you'll be paid, it would only influence that through your education. That is why it satisfies the exclusion restriction condition. Do I have to explain this again? Or if someone has a question? So if we use a father's education to serve as an instrument, it is because we are convinced, or for those who wrote that paper, we're convinced that a father's education does not directly influence the child's wage. If you go sit in an interview, they wouldn't be asking you your father's education before they determine how much they will pay you. It is your own education that would influence it. But your education is also influenced by your father's education, so that sorts that out. Now, let's go through the two-step procedure, and then we would now also use a direct Stata code to run that. When we finish, we'll compare the estimates from the two-stage procedure step by step with that of the Stata code, the direct one. Then we see what is playing out. I have my Stata code here, which I'll share with you at some point. Can you see my screen with the Stata software?
Yes, we can see you, Doctor.
Okay. So this is the data. In Stata, let me see if I can make this slightly big for you. So we read this on education. And please, if you could be writing down the coefficients for me, that would be good, at least so we can compare. Let me give you a few seconds. Just write the coefficient of education, the 0.109. When you are done, prompt me. Are you done? All right.
Yeah, done.
Okay. So this is the effect of education on wage that we think is inconsistent. It is not properly estimated. We feel it could be either biased upwards or biased downward. Now let's go through this. And I want to prompt you again on this. This is the first stage. We want to find the influence of the father's education on the child's education. If you run it like this, you may not get exactly what I have in my slide, which I'll share with you. So we have here. You realize that the sample size here is 753. The sample size here is 428. So what you can do in Stata is to restrict your analysis to the same sample size as the initial one. So when we estimated the effect of education on wage, which the one you recorded, which is the 0.109. In our second estimation, where we wanted to find the effect of the father's education on the child's education, let's restrict that using if E sample. So what if E sample does is that it restricts the second estimation you are going to do to the same sample size as the initial one. In your practice, sometimes a reviewer will pick up on some of your estimations and say that why are your sample sizes different, especially if you are comparing estimates. So this is a nice way of restricting it. So we now have the father's education influencing the child's education, which is 0.269. This would be your first stage estimate that you report in your paper. Now, let's predict the education hat. This is your code. So predict the whole education hat. Once that is predicted, it is stored as education hat here in your data. So the education hat is here. In our next stage, realize that when we estimated the effect of education on wage, we used the education itself. So let's copy the same code, move here. Now we will not use education. We will use education hat because it has gone through the first stage. So the effect of education on wage is now 0.059. And if you compare this to the first one, what does it say?
This one is smaller than the first one.
Reduction.
So if there's a reduction, it means that if you don't take care of the endogeneity problem, the effect of education on wage will be biased upward. But once you take care of education, it now drops the estimate and gives you a more realistic one. Let's forget about the fact that it's not significant and all that. Now, which of the Stata codes are you conversant with in terms of estimating instrumental variable estimation? There's IV-Rec2, there's IV2SLS and all that. So let's use IV-Rec2. In IV-Rec2, you have this, you have your log of wage, you have brackets open. The education here is the child's education depending on the father's education. And then we add first because we want to report the first stage regression and all that. When we went through the two-stage process, we had 0.059, right? Here. Here. Did you record it on your paper? And then after going through the two-step process, after using the code, it still gives us the same thing. So it is about you knowing the two-step process and all that. What I'll take you through in this meeting is give you other variants so that you use them as robustness checks. Unlike the two-stage procedure, which is the standard one that we know, there's also one that is called the control function approach. The control function approach works slightly different from the standard 2SLS. The only difference is with the standard one, which we just applied here, you predict your outcome variable and then you replace the predicted one in the model. But with the control function approach, you predict the residual and you introduce the residual as an additional variable in your model. So let's try that. Where in our first stage, we estimate the effect of the father's education on education. So we reg education using the father's education. Your second stage is to now predict the residual. So if you are predicting the residual, similar code as we had initially, but slightly different. So you predict, same double here. Now it's education resid, not education hat. And then you have residual here after as an option. That also gets introduced as a new variable here. So if you want to now estimate the effect of education on wage, you come back, you reg, education is here, the wage comes first, sorry. Education follows. Unlike previously, where you replace education with the education hat, which is a standard 2SLS approach, now you bring the same education and you introduce the residual of the education. This also gives you this. And strangely, this one is significant, right? We had an Indian professor who would usually not go for the standard 2SLS and will always go for the control function approach because he feels that is better. But in all, these are the approaches that you have at your disposal. Let me estimate all of them together, then we can compare. So initially, we had this. I'm using a do file, so don't worry. So this is what we had. When you estimate the OLS, we had this 0.109. We went through the two-step, and then we had this education hat being here. And then we used the ivrec2 command and had that. So at least you can realize that whether you use the two-step procedure step by step or you use the ivrec2 command, you still have the same thing. Now, I would introduce more variables into the model, such as experience and the squared term of experience. So we go to the multiple regression stage where we have this. So we have we have wage being influenced by education, experience, and the square term of experience as the OLS. Our estimate is virtually the same here. Now we go through the step where we introduce father's education to influence education. We still have our two control variables here. When we finish, we predict the education hat. Because we already have education hat here, I just call the second one education hat 2. That is also predicted. Now I can regress education on wage. But because we have now predicted education, let's use the education at 2. Introduce our experience and experience squared. So it has now improved. Someone would say it is now significant at 10%. Not strong, but at least if you compare the coefficient for education now and the one where the endogeneity problem had not been resolved, it means that if you had not resolved endogeneity, the effect of education on wage will be biased upward. Has anyone got a question?
Yes, I've got a question.
Okay.
Could you go over the two criteria that the instrumental the instrument should meet?
Okay, so you mean the relevance and exclusion restriction assumption?
Yes, yes, exactly.
So the relevance assumption says that your instrument must have a direct relationship with your endogenous variable. Our endogenous variable in this case is education. The instrument we are using is father's education. You want
Okay.
father's education to be directly related to the child's education. And if we say directly related, it should have a significant association with the endogenous variable. So in this case where we have reg, the child's education, which is here, or the person's education, and then the father's education, which is here. You want them to be significantly correlated. So this one tells you that the more a father is educated, the more the child also gets educated. If the father attends school for an additional year, it would also influence the child to also attend school by 0.2824. So the relevance assumption in this situation has been satisfied. Is that okay for now, Jerry?
Yeah, that's clear.
Then the second exclusion restriction assumption is that the instrument must not have a direct relationship with the outcome variable, which is
Oh,
wage. And it must only influence the outcome variable through the endogenous variable. And
okay.
like I pointed out, the relevance condition is what we have estimated here. So it is a statistical exercise. You can always estimate it, go through your first stage, pick that up, report it, and you must always report it. When it comes to the exclusion restriction assumption, you don't have to do any estimation. You have to argue it out. And the argument we put out here is that a father's education does not influence the child's salary directly. I initially pointed out that if you go to sit in an interview, how much your employers decide to pay you has nothing to do with your father's education. No one sits in an interview to say that because my father has been educated up to the university level, pay me this much. No employer cares about that. So your father's education does not have a direct influence on your salary, but your father's education can influence your education, which will in turn influence how much you make. Is that okay for now?
Yeah, that's clear. But I have a follow-up
Mm-hmm.
question. So my question is, so does the instrument you have chosen here, which is the furthest education,
Mm-hmm.
does it solve the endogeneity problem?
Yes, it does.
Yeah. So that means at the start of the presentation, you made mention of one variable which may be contained in the error term, which is innate ability. So if I understand you correctly, the introduction of the instrument, that is the father's education, rules out the influence of, say, the innate ability on the child's education.
Okay, so this is a correct question. The innate ability in this case, which comes as a result of an omitted variable bias, the father's education should have a relationship with that innate ability and also the education.
Okay.
And if you are born into a household where, let's say, your father is educated, through your day-to-day conversations with your father, you tend to build up certain psychological skills that you may not be able to directly put a hand on, right? So we talk about, let's say, either self-serving bias or all of those factors that you build up. I'm trying to get the right term. So in psychology, they have this concept of locus of control, right? And there is this external locus of control, internal locus of control. These are stuff that you build up while you are growing. Depending on your father's education, he helps you to build up some of these as you move along. So your father's education has an influence on the innate ability
Innate
that you have.
ability. Okay.
And then that also influences your own education. But we don't expect your father's education to determine how much your employer will pay you.
Okay. Yeah. I think it's
Thanks
clear
for
now.
thanks for picking that up.
All right. Thank you too.
All right. So in your quest to engage in instrumental variable estimation, like I said, there's this standard two-stage least squares that we have, which we first put in the father's education. We predicted the outcome variable, which is the education hat, because in the first stage regression, your endogenous variable becomes your dependent variable. So you predict the outcome variable. You can also go by the control function approach, where in this case, you predict the residual, and then you introduce the predicted residual into your model as an extra control variable to solve the problem. Depending on which of the methods you want to use, it would also influence what you report in your table. So what I'll do is to estimate them and then we now compare, but we are now at the multiple regression stage. So in the multiple regression stage where we introduce experience and experience square, we now predict education hat 2. The two-step procedure is here. So we now have education hat 2. And education hat 2 compared with just education here. The way I estimate it, it may look quite clumsy to you. Let me show you what I have in my do file. So in this do file, I start off by having wage, education, experience square, and then R here is just robust. The code I use in exporting my results into Microsoft Word is outreg2. You can also use that if you don't already use it. Then I go through my first stage regression where, because I want to now find the influence of a father's education on the child's education, I now make education the dependent variable here. The father's education comes experience square. I restrict it to the first sample. Then I predict the education hat. Once I have predicted the education hat, this education hat now comes to replace the initial education here. So now we have the reg of wage, education hat 2, experience and experience square, same command to export it into Microsoft Word. I'll share this do file. So if you don't already have it, you can install it using SSE install. Then this is a typical ivreg2 command where you have wage, you have the education being influenced by the father's education, you have experience, the square term of experience, and your robust plus your first stage. This first here resolves the problem for you because your first stage where you predicted the influence of a father's education on education, you need to know that coefficient and then you report that in your table for publication. I'll probably show you how you report that. So this first gives you all that. Let me copy this and show you what I was talking about. If you have this code and the first is not there, all you get is this. You get to have the effect of education on wage, which has resolved the endogeneity already. It tells you that at this point, the effect of education on wage is 0.70, all that. The father's education has been factored in. But if you add first to your code, it gives you the first stage regression, so you can report. Now, this is what we had initially. If you scroll up, it also reports the first stage for you. Tells you that the father's effect on the child's education is 0.270. So you report this coefficient, report the standard error, and then you report this F statistic. So let me pick up the Word document which we had. This one. If, for instance, this is all I had, because I feel this and that are the same, let me just drop this. So it is up to you to create, let's say, more rows here. And then type in first stage. Here we have father's education. The effect of the father's education on the child's education is that. So let me maybe just copy these two. You can copy this here, copy this. This as 0, this as 0. Maybe you leave this by 1 decimal place. Since this was significant at 1%, you report that. Did you pick up something I was doing wrongly? It's not supposed to be in this column because this is simple regression. Once you have this, your relevance assumption, which has been satisfied, is also being shown in your report or in your table. So your reviewer wouldn't come hassling you that what shows, how does that show? It is here. You also need to inform your reader that the model that estimated this was significant in its general sense, which is the F statistic. If we go into Stata here, this F statistic that was reported here is all you need, the 86.77. You report that here and tell your reviewer that based on the stock and Yogo assumption that the F statistic must be bigger than 10. This is also bigger than 10, so it's sorted. Then you argue out your exclusion restriction assumption and your paper is complete. Don't go reporting too many things. I mean, if you transition from a typical econometrics class where you are taught so many post-estimation results for this, report that, it is not everything that is relevant now. These two should be fine. You're good to go. Any question? Any question?
I want to be sure if I've not missed any of the training. Is it the fourth session, fourth training for the entire quant journey?
This is the third one. Yeah.
The fifth.
No, the third. The third one.
Okay. All right, thanks.
That wasn't meant for me. All right. There are more questions to answer in your journey, or how to make your paper stand out and not get a reviewer asking too many questions. In most cases, to get your paper published, especially in a top journal, you have to be, to some extent, in the mind of the reviewer. Ask yourself as many questions as the reviewer could ask, and you try to answer them before they come at you. You also must convince the reviewer beyond reasonable doubt. So, some of these questions are what we will answer here. I've answered one part of the question. You've satisfied the relevance assumption, you've satisfied the exclusion restriction assumption. I've also told you that I had an Indian professor who prefers the control function approach to the standard two-stage procedure. So what do you have to do? You have to now move into your section in your paper where you talk about robustness checks. So if, for instance, your paper is sent to my professor who prefers control function approach, yours will be to now estimate the control function approach, report that in addition to this, so that you ward off that criticism. Is that clear at this point? The next point is, what if the instrument is not even as strong as you perceive? Sometimes a statistical exercise like what we have here, where you've reported, as in this one, where you've reported your first stage regression, and in that first stage, we use the education as the dependent variable, the father's education. What if it's not strong? You may want to then maybe think of an additional instrument. In this case, we were just talking about the father, the father, the father. If a mother is also educated, it would influence the child's education. So you can introduce an additional instrument. So let's go back, pick on our code. This is the code we used. And this time around, I'm not going to go through the two-step procedure because I believe you already know. This is the code we used. Father's education influencing the child's education, and now the education going to influence wage. You can introduce the mother's education here, which is the variable here, also into the model. This takes us to the case of identification. If you have one endogenous variable and one instrument, that's exactly identified. If you have one endogenous variable and you have two instruments, that's over-identified because the instruments are more than the potentially endogenous variable. And there's also a case of under-identification, but that is not part of this exercise. And in fact, it is not correct. So you don't even think about it, as in you having two endogenous variables with only one instrument. Not the case. So once you have this and you have your first here and all that, we have introduced mother's education. And because you have introduced mother's education and there is now an additional instrument, the over-identification test is also important. And you must report that in your table. The good thing is, because we added first, if I scroll up, my first stage regression is here. Now that you have this, you have to report these two. So since we have more time, let me outreg the outcome. This is what we have here. This, that. We can now talk about first stage, talk about father's education, talk about mother's education. Don't even know why I dropped that too. Now let's go back and pick those ones from our first stage. So let me copy it as a picture so I can at least easily pick that up. Did I pick up the right thing? No. We want the first stage regression where we have the mother and the father. So this is it. So the effect of the father's education on that of the child is, if I round up to 3, I would be left with maybe 0.190 kind of. And then that is significant at 1%. So the standard error that you have here is what you report. Then that of the mother, the standard error here is what you report. So this is also sorted. Your next is to report the F statistic. The F statistic is reported just beneath the first stage regression table. So report that here. Now your next statistic to report comes after the second stage regression has been reported. So that is your Hansen J statistic here for over-identification. Probably copied the wrong thing. So that should be 0.443. Now this is your statistic. So yours is to know how to interpret it. Now there's AI. So if you forget the interpretation, just go and check. The null hypothesis for the Hansen J statistic is that the over-identification is justified. The alternative hypothesis is that it is not justified. So since it is not significant, you reject the alternative hypothesis and then go for your null hypothesis. And the null hypothesis is that the model is over-identified. And so this is correct if you combine both mother and father's education to influence a child's education as an instrument. Any question? Any question? Okay. Since you don't have a question, I have more questions. We've gone through steps. We have the returns to education model. We have education influencing wage or the returns to the person's education. We have used father's education as an instrument to influence the child's age, which then later influences wage. We've gone through the standard 2-stage procedure where we first introduce the father's education into the first one, predict the Y hat, which is the education hat. We introduce the education hat into the model. And then we've also used the Stata code to resolve that. We've also realized that using a father's education alone could not really do the work as we expected. we have now introduced a mother's education as an extra instrument. So in this case, there's one potentially endogenous variable, which is education, and you have two instruments, which is the over-identification situation. We've learned how to report our findings to make sure that we are in the right scope. We've also noted that in as much as the standard two-stage least square procedure works, some people are in favor of the control function approach. So we use the control function approach as a robustness check. And then in your write-up, you create sections. In your write-up, you create sections to resolve all that.
We can't hear you.
Yeah, I'm here.
Okay, we can hear you. I'm sorry.
Someone called through, so I had to find a way to deal with the person. So we've now gone through all of these stages. The other question is, what if you don't have an instrument? For those who are into time series and macroeconomic analysis, they usually don't have an instrument and they don't have to deal with this. Some people have estimated this returns to education model and also proving that even if there's not an instrument, you can still resolve endogeneity. Yours is to rely on the heteroscedasticity in the data to generate internal instruments. In that case, you wouldn't have to go out there to look for instruments yourself, but the data in itself has a way of picking up the widespread nature of the distribution of the variables to produce internally generated instruments to help your case. And that was introduced by Liouville. So we have the Liouville two-stage least squares. I wouldn't go through statistics here, but I would show you how it is estimated in Stata. The good thing about this in Stata is that you have the ivrec2 command, which I showed you here. This ivrec2 command, this. So we introduce the father's education. If you don't have this command, please install. It's just SSE install ivrec2. And it will install it for you. If you want the code for the Liouville, all you do is still install ivrec2 but add H. Once you add H, you will now get the code for analyzing your instrumental variable estimation model when you don't have an instrument. So this, as we have, you now come into your code and you add an H to this. Is that clear for everyone? Now, the ivrec2, which is the Liouville situation, is quite an interesting case. There is a part where you can use internally generated instruments with no external instruments. The father's education, the mother's education, these are external instruments. So if you don't want to use any external instruments, just strip this part off, take off the tests, which we don't need for now. So this is how to go about the Liouville two-stage least squares when you don't have an external instrument. And I can tell you for a fact There are many cases where finding an instrument is hard. There are also almost every time where you have to convince the reviewer beyond doubt. So in my papers, I estimate the standard two-stage least squares, which is what everyone wants. I sometimes estimate the control function approach as a robustness check. And then I tell my reviewer that even if you have a problem with my instrument, in a case where I did not use the external instrument and I only used the internally generated instrument based on the heteroscedasticity in the data, I'm still finding a consistent outcome. So that pushes so many of the questions they want to push to you away, and then you can easily get your paper published. So the Liouville two-stage least squares gives you this. I'll find you a data that makes this one even more interesting because this study only used external instruments. But the Liouville gives you this and then gives you that. What you need to report in the Liouville case is the JP statistic. This JP statistic must not be significant. And so in this case, it works. We didn't find our education variable here to be significant, but it's fine. I'll show you the CAD data set that does that for you. If you want to estimate the Liouville where you don't want external instruments, you just put the equal to sign here, you leave it. Once you leave it and there's no variable here, it is you telling the software that go out there, go into the data set, generate an internal instrument based on the widespread nature of the observations within the data set, and then get the instrument for me. If you want to add both internal and external instruments, all you do here is not to leave the side open. Now include the father's education here, over here. Once you have this, it is going to use internal instrument and external instrument, because for Liouville, the task is to use internal instruments. If you introduce an external instrument, it uses both. Again, in my papers, even though I'm doing robustness check, I still report both the internal and external instruments in the paper. So I have one of the papers that I have here. So this is a paper on trust in banks, financial inclusion, and the mediating role of borrower discouragement. I have my Liouville here. This is not even my main model. This is a model I'm using for robustness check, but I still report the one for internal instruments only, and then internal and external instruments. So if there's any day where you are confused as to what to report, you can always find some of my papers. Even me, who keeps writing and reporting them, sometimes your mind wanders. So you just pick an old paper, see what to report, how to report it, and you should be fine. But then again, all the models I've been talking about are, I would say, extra. But your go-to model should be the standard one. If it is not working, I've also seen cases where the internal instrument only did not work, and the external plus internal worked. And because it is not my main model, I can just forget about this one and then report this one only in my robustness check. This is me trying to convince the reviewer that I've given you a model which is following the standard two-stage least squares approach. I've also applied the control function approach to let you know that both methods are giving me consistent results. Mind you, the coefficients will not be the same for both the standard two-stage least squares and the control function approach, but at least they should be consistent. Consistent in the fact that you are saying your IV estimate has the coefficients being smaller than the OLS. If the standard IV estimate is smaller than the OLS, then the control function estimate should also be smaller than that of the OLS. That is the consistency. We've also gotten to the point of telling the reviewer that in as much as I've got models that have external instruments, I'm even using one that is not using any external instruments, and my coefficient is still smaller than that of the ordinary least squares. And so, trust my findings. Any question?
Yeah. No, so Koomson.
Yep.
So, based on your experience, what is your comment on using only Lubel's external instrument? I've seen papers doing that, but based on your experience, what's your comment on that? That is trying to exploit that approach to write a whole paper on its own in events that you don't have internal instrument.
So, Kingsford, what was your best food for dinner?
My best food for dinner.
Yeah.
I think maybe jollof. Yeah.
Because it's heavy, right?
Yeah. I mean,
On,
yeah.
on a
Yeah.
day when you don't have jollof and you still have to eat because you don't want to die in your sleep, what would you do?
It depends. Maybe for American culture sake, I'll go for Chick-fil-A.
Okay, but it's light, right?
Yeah,
So,
very light. Yeah.
so in this case, your jollof is the standard two-stage least squares, right?
Mm-hmm.
But in the absence of an external instrument, you go for the Lubel. I have personally written a paper where I use the Lubel only, but it is because it was a book chapter, and I know no one is going to come after me. If I'm writing a standard paper for a top journal, I'll go to every length to find an external instrument because they will come after you. And then I've also seen people who have published in very good journals. I've even seen a study published in World Development, a journal most development economists want to publish in, and they used only Lubel. You can be lucky. So it's just a matter of choice, but for me, and per sequence, or I would say ranking, the standard two-stage least squares is your go-to. If you don't have an external instrument, then you can use the Lubel. That's what I would do. Does that answer your question?
Yeah, I think that makes sense. Thank you so much.
Yeah, I mean that is how I go about it. And sometimes people feel you are overdoing it because in one paper you have standard least squares, standard two-stage least squares. In the same paper you are reporting control function approach. In the same paper you are reporting Lubel, even internal and external. I mean, it is not our choice to overburden ourselves with too many estimations, but it is you sitting in that small corner of your house trying to think into the mind of the reviewer that what if it is like this? Okay, if this is what if, I've given you this. If your other what if comes, I've given you that. I even go to the extent of estimating propensity score matching to even ward off questions on bias from self-selection if I have a binary variable as my main variable of interest. And as a point of advice, don't be too interested in having too many variables of interest in your model. Make it simple. If you see 3 variables in my topic, It is not because I am estimating the influence of one variable on those two variables. No, the other one is maybe serving as a mediator. And that is where research is also now. So I have not done research to confirm what I'm about to say, but I could tell that over time, ordinary least squares and everything were just a go-to model for people until they were pushed to now assert causality using instrumental variable estimations and all that. So if you didn't have that, it was more or less a no-go situation. Even now, especially in economics, if you don't have instrumental variable estimation, you will likely not get your paper published. But we are now in a newer era where you estimate all of these models just to convince the reviewer that your finding is correct, and it's not enough. Your next step you have to go to is to answer the question as to, so how does this happen? How does education of a person influence their wage? What is the mechanism? The mechanism is not part of my study, but that's advice for you. Once you go through all of these stages to estimate your models, tell your story and everything, try to answer the next question. What does it go through? How does this happen? Does it go through a moderation effect? Does it go through a mediation effect? And you should be fine. Let's estimate our last set of models and we can say goodbye. So someone else estimated the returns to education model, did not use father's education and mother's education as the instrument. The person rather used the nearness or the closeness of the person to an education institution as the instrument. And so we'll go through that. And that is David Card. So for David Card, I'll just rope in the data. Then we go through. So this is the card data. What card wanted to do. Okay, so let me do this. So here we have wage, we have education, we have experience squared, the person's race being here. I don't know much about this SMSA. If the person lives in the south and the region the person lives in. This is not instrumental variable estimation. This is just estimating the effect of education on wage without addressing endogeneity. So just like you did initially, would you want to record this down for me? This is the effect of education on wage and 0.07469. Once you have that, give me a prompt. Okay, so someone just prompted me. So it means that you all have noted it. Okay. At this point, I assume that you know the two-stage procedure. So I'll just use the Stata command where I've got IVREC2, I've got wage, I've got education, and then I use near C4. So the near C4 is equal to 1, okay, if near 4-year college. So it estimates the effect of education now as this. What was the initial effect of education? What was the value?
0.07.
0.07. And now we have 0.131. So this person would also argue that if the endogeneity problem is not resolved, the model will understate or underestimate the effect of education. But once the endogeneity problem is solved using the instrument, this happens. In my code, I did not specify the first. So it did not give me the first stage equation. So let me now introduce the first and re-estimate. What you will have here is usually the second stage model. The first stage will be reported up there. So what's the effect of the near C4? So you see, if the person is nearer to a 4-year college, then it increases the person's number of years in school by 0.3198. The F statistic, which should always be reported, will be here for you. Now we come down here and we have this. Take note, for this same model, which I estimated using IV-Rec2, once you add 8 here, you've now moved into the realm of Liouville two-stage least squares. If I leave this instrument in here, it means I'm instructing the software to estimate a Liouville two-stage least squares using both internal and external instruments. But let's first deal with the internal only instrument. So I will remove this. Once I have just equal to here, nothing here, I don't want too many things reported, so let me take out the first. It now estimates and gives you the effect of education being this and that. Now, this is the consistency I was talking about. When we estimated the OLS, we had 0.07 for the effect of education, right? When we use the standard two-stage least squares, which is here, we had 1.31. It means that the IV results are bigger than the OLS results. So even if you are using a different method, like the Liouville two-stage least squares, which uses only internally generated instrument, the coefficient should still be bigger than that of the OLS. In practice, the two-stage least squares using Liouville or the Liouville two-stage least squares using internal instruments only would have the coefficient also being smaller than the standard two-stage least squares, mostly. So take note of that. This is 0.131 bigger than which is bigger than that of the OLS, which was 0.07. This is also bigger than the OLS, but it is 0.083. But the consistency is clear. Let me click on this and now introduce the farthest age. Let's use the near C4. You would realize that the near C4, which is now in this case going to combine both internally generated instruments and external instruments, the coefficient here will be bigger than the internal only instruments, but will also likely be smaller than that of the two-stage least squares. The good thing about this is it reports this table for you very beautifully. It tells you that the standard two-stage least squares result is here. The internal instrument is here. And the one that uses both internal and external instruments is also here. So see the comparison. The standard least square, the standard IV has 0.1315. Internal only instrument is 0.08362. Internal and external instrument has 0.08541. But again, a word of caution. If you are writing a paper as this, don't go and report all of these into your table. I would report this one only, the standard IV, in my main write-up, my main paper, the first part of your results presentation, because that is the standard one. Then this and that I'll report as robustness check. Any question? See more people here, but the questions are not coming. So I see Kwesi Kwanzaa, I see Richmond, Jerry, Vanessa, I see Danny, I see Frank Kujo, I see Jesse. Yeah,
I
Danny.
have a question. I don't know if it's. I just want a clarification. So the current regression on your screen now, is standard IV generate internal instrument and external external and internal. The standard IV, can we okay, the standard IV, is it that we can think of it as external only kind of?
Yep.
Okay. Okay.
So the standard IV uses external instruments.
Okay.
And if you check the slides while I was going, it says that the IV must be external to the model.
Okay.
Yeah, but in standard practice, we don't call it external only, but at least we know that it's an external instrument. Who has got a question? We still have time. So ask all your questions before we leave this place. But I mean, to make your work easier, always find ways to make the best use of Stata. So just like the model I presented, I have just run the OLS here, use this code to export my results into Microsoft Word. I have the IV here, which is the standard one. I have, so let me probably put standard here. Then there's Lubel, there's that. So once all that is estimated, tells me the file is already there. So it pulls it for me here. So we've got the OLS, we've got the IV, we've got the Lubel internal instruments only, we've got Lubel internal external, and then you can have first stage, as in, let's say the near C4. You report your F statistic, report your JP value, this and that. Also note that because the Lubel model that has internal and external instruments in there, you still have to report the F statistic for that one. This one, you don't need an F statistic. Well, at this point, I think I've come to the end of my session. I'm looking forward to you asking questions. If you don't, then we will probably pick at the other side. Jerry, do you have a question?
It has to do with Stata. I don't have a copy at the moment. I don't know if anybody can help.
Does anyone here have Stata? Because it is not to be shared. Most people
Yeah,
try to stay away from that, but I'm sure if you could put your email address here, someone will
okay.
definitely reach out. Okay, so Frank was putting some takeaways here. Yeah, I'm going to share both the slide and the Stata do file plus the two data sets. One is called MROS, the other one is called CAD. So how many files do I need to share? Um, 4. But I guess everyone could probably download from here, right? Let me see if I could attach them so you can grab it before we leave. So this is one of the data sets. The second one I used. This is the first data set. I've given you 4 files. I'll try and download them.
Yeah, I've been able to download them, so I will share with those who could not make it. Yeah.
That's all right then.
Yeah. So, yeah, Dr. So what are your final words? Generally, in terms of research and everything, I think you're the best person to also advise us. Your final words there.
I think with this, I rather go for a question and answer approach than to think that I know,
okay.
to think that I know everyone's problem and solve them. Maybe your question,
Yeah.
your questions will trigger me telling you more.
Mm-hmm.
So if you have questions, or if anyone here has questions, let the person bring the question and I will answer.
Fantastic. Yeah.
Okay.
Colleagues,
Then I have a
the floor is
question.
open. Yeah, Dennis, sorry,
Yeah, I
Dennis,
have a
go.
question. So, what
Yeah, go
advice
ahead.
would you give to early career researcher generally, how to handle DEX rejections and how to handle rejections in general if you are starting your career, and what strategies can you put in place to be able to publish at a higher impact journal and also publish frequently? It's like three in one question.
Many questions in one. So publishing in top journals is similar. Comes with what I told you. Reviewers over there are very detailed, right? So you have to think about potential questions they would ask. And let me give you my typical example. When I started publishing, my biggest dream was to publish in an Elsevier journal. If I see the logo of the journal and that professor standing behind beneath the tree, oh my God. But as many times as I tried, I wasn't getting in there. But you need to look out for people who are doing it and either to ask them questions directly or study them from afar. One of the things I did was, if you come onto my computer, I've got people that I